Welcome guys to another tutorials on frequency distribution, and today's tutorials we're going to take a look at histogram. The histogram represents the frequency distribution as I wrote it down here, but I want us to go ahead and discuss some of the properties of this histogram. So I'll go ahead and start here and say that so let's write the properties of the histogram. Now, first I'm going to put down here will be all the values you could find in the horizontal axis, because it's in a graph form, so it has horizontal axis and vertical axis. All the vertical values you could find in the vertical scale or vertical axis, they are quantitative, like we discussed before. They have values, so they are quantitative in nature. And then the next thing we'll find with the vertical axis is that, so let's put the vertical axis is that they measure only the frequencies. So here they measure they measure just the frequencies. Let's say just the frequencies. Keep typing stuff wrong. Frequencies. Whoa, what a big mistake. Okay, they measure just the frequencies. And then the third thing I would like to talk about will be the bars. The bars touch each other, and that's the difference between the histogram and the bar graphs. So make sure that the bar touch each other. And what makes the bar touch each other brings us to a topic called class boundaries. So we're going to discuss class boundaries, because if the class boundaries of consecutive classes are the same, they will touch each other. So class boundaries, for example, here will be, let me go ahead and define it, and then we'll go and take an example from our previous class. It separates the classes. Basically, it has, next thing it does is it is the distance between the upper limits of the first class and the, let's say, the lower limit of the consecutive class. So that would be the class boundary. So in our case, let's go ahead and take the question that we were dealing with before, the table, which is this table. So I'll replicate this table here so that we don't have to go back and forth. So let me go ahead and put back this table in here. So we have our previous table, which has lower limits and upper limits of consecutive classes, and we want to be able to construct the class boundaries. So let's find any table of interest. Let's go here and write, let's put the lower class boundary, and let's go up here and write the upper class boundary. Now, okay, so once we have that, let's first find the class boundary for this distribution here. Let me go ahead and write here class boundary for this distribution. So it's class boundary here will be what? We define a class boundary, we said, is the distance between the upper limit of the first class. The upper limit of the first class is 18. The lower limit of the next class is 19. So the distance between them will be 19 minus 18, and that will give us our first class boundary. So what will be the answer here? The answer will be 1. The next thing we do is we take half of that, half of the 1, and that gives us 0.5. 0.5. Half of 1 is half, which is equivalent to 0.5. And what we do with this 0.5 is we go to the previous limits, the lower limit and the upper limit, and we subtract 0.5 from the lower limit and we add 0.5 to the upper limit. So for example, in the case of this, the first class, in the case of the class 1, we know that the lower limit becomes 7 minus the class boundary for the first class will be, let me do this, in the case of class 1, the lower class boundary will be equal to, we take 7 and we subtract 0.5 from that, or you could say 0.5 most preferably, and that's going to give us 6.5. And then the upper class boundary for that, it's going to be, we're going to take the upper class boundary is 18, and we're going to add 0.5 to that, and that gives us the 18.5. So that is the lower class boundary and upper class boundary, and that's what we're going to put here. So here is going to be 6.5, and next one is going to be 18.5. This thing got, let me go ahead and bring it here a little bit. Alright, so this is going to be how it works, and you could easily do it without having to write class 1, class 2, class 3, and etc. So all we do is just subtract 5 for the first one, so 19, we have 19, so it becomes 18.5, and then the next one becomes, well, let's do here 18.5, and the next one becomes the 30 becomes 30.5. We're adding 5 to 30.5 to 30. Now you realize something, that now the boundaries are the same. That means that when you construct the graph, it's going to touch each other, and that makes the difference between the bar chart and the histogram. So let's go ahead and finish up the table, and we're all set to construct the histogram. So the next one after this, the lower one is 31, so you're going to have 30.5. 43 becomes 42.5. 55 becomes 54.5. 67 becomes 66.5. I don't know why it's gone that way. Well, it's supposed to be here. Then you have 66.5, and then the final thing you have here will be 78.5. So that's what we're doing basically. Alright, the next one we're gonna do here is to add 0.5 to each to the upper limits. So you have 42.5. Next one will be 54.5. So we just keep going that way, and then we get to 66, and that becomes the 66.5 and 78.5, and then here finally we have 90, and that becomes 90.5. So that finish up the tutorials on things we need to know about histogram. In the next tutorials, we're gonna construct the histogram, where you're gonna see the horizontal axis, the vertical axis, and how the bars work and come together. I hope the tutorials went well.